So what I'm going to be doing here is I'm going to be writing notes on the screen here and explaining to you exactly how it works. So we're going to be going through chapters 2 and 3 in this taster session. So this is essentially an hour and a half out of a full day online live classroom, which is a little bit similar to a face-to-face tutorial, but obviously we have to work quite hard to get some interactivity across the computer. The reason for that is if we put you all on microphone, it slows down the system so much that we just can't get anything to work. All right, well, let's move on to something a little bit more messy. Now, as actuaries, we spend most of our time making financial sense of the future, not accumulating, but working backwards. And we're going to be working with something called present values. Now, what might be happening in this case is, say you're going to pay a pension, an annuity or something like that, and you know what the payment is, but your question is, how much do we need to invest now in order to meet that payment? So let me draw a little diagram to show you what's going on. Supposing we're at time 0 and we invest £100 at 5% per annum effective. Well, I would multiply by my accumulation factor of 1.05. And I know that will give me £105. So what we're trying to do now is go the other way round, saying, well, if I knew I had a payment of £105, how would I get back to my £100? Well, your natural thought is, let's divide by 1.05. What the notes actually do is multiply by 1 over 1.05. And this is called our discount factor. This is what we multiply by to go backwards in time. Now, in general, instead of 1 over 1.05, we'll have 1 over 1 plus I. What letter do we denote 1 over 1 plus I with? Oh, Helen, very quick. V. So we use V. D we'll get to in a second. So I'll show you why it's not D in a little bit, but it is V. Okay, so V is what's called our present value, and it's what we multiply to go back one time period. So let's apply this with an example. Supposing we have to make a payment of £100 in 5 years and a payment of £200 in 8 years. And we think the interest rate, or the amount our investments will earn, is 4% per annum. And what I'd like to do is find the present value. Okay, so what I've got for you here, because I want to see how your working's going, is I've got a little question box up here. So you type your answer in the little box up there, and if you type your working, I'm able to give you feedback. So in a normal face-to-face tutorial, I would come round and look at your working, whereas if you type it in that box, I can see what your question is, I can answer you directly, and also give you some tips. So you could write the final answer if you wanted, or you could write your working, and then I can tell you whether that's on the right track or not. So Siddharth, I'm afraid that is not correct. But if you type in some working, I can help you get the right answer. Okay, Helen, yep, you're doing the right method. Akshay, the £100 is in 5 years, not in 4 years. Priyanka, you've given me a discount factor, but what are you going to do to calculate the answer? James, yes, almost spot on. Something's gone wrong. Let me just find it. 5, 8. No, your working's good. Oh, you've got 5%, whereas it's 4%. That'll be why. Okay, what you would type in the exam is you would say, I've got £100. I'll times it by V if I was discounting 1 year, but we're discounting 5 years. So we times it by V to the 5. And then the £200, we're discounting 8 years. Now, in terms of calculation, do you remember V is 1 over 1 plus I, so it'll be 1 over 1.04, so I could do that. All right, which unfortunately is a bit frustrating. So what we tend to do is write that. The other one's totally right, but this is slightly quicker to work with. So 200 times 1.04 to the minus 8. So if all goes well, you would get £228.33. Okay, yeah, that's right, minus 5, minus 8. Okay, well that's the idea. Let's make it a little bit messier, because in real life, interest rates change. Okay, and returns on our investments change. So what I'm going to do is do 5% for the first 8 years and then 10% for the next 4 years. And we'll go European, we'll have 150 euros and 300 euros. And once again, I'd like you to find the present value. So I'm going to pull up a little box on the screen for you to type your working in. Do type your work, and it just allows me to find out what errors you're making, whereas if you just do the final answer, I can't say anything other than it's right or it's wrong. Why is the second term not 200 times 1.5 to the minus 3? Ankit, it's because we're discounting to times 0. So, forgive me. The present value is at times 0. So it needs to go all the way back to times 0. If you just do minus 3, that would only take you back to here, which isn't the present value. The present value is at the present time at times 0. Okay, so let's see what we've got coming in here. Yes, Gunjan, you've got the right answer. Shubham, you've not done the right thing. I think it's because you've discounted everything at 10%. Show me some work and I can help you a little bit further. James, you have discounted for 10% for 12 years. The 10% is only for 4 years. Okay, we've got any other 240s? Barbara, that's correct. Akshat, that's correct. Doing the right thing. Okay, so we've got a mixture of answers here. So, if you were writing this for the examiner, the 150 needs to be discounted for 8 years at this 5%. So you could write it like that for the examiner. And then the 300, this is where a lot of people went wrong. We need to do 4 years at this 10%, and that will take us back to time 8, and then we need to do 8 years at that 5%. So in terms of what you'll type on your calculator, 1.05 to the minus 8, and then 300 times 1.1 to the minus 4 times 1.05 to the minus 8. Okay? So a lot of people doing the 1.1 to the minus 12, but the 10% doesn't count for 12 years, it's only for those 4 years. Alright, so we can now work out present values, and to be honest, when you're doing CT1, most of your time will be spent calculating present values. Because in real life, you know, if we're working with pensions or with insurance, we know roughly what the payments are going to be in the future, but we want to know how much it's going to cost now, i.e. the premium.